In this question, we are looking at conservation of momentum. Object P and Q form an isolated system, so we can use the principle of conservation of momentum to solve this problem. For object P, it has a mass of 6, and moving is at a speed of 3. So as you can see in the diagram here. For object Q, it has a mass of 2 and a speed of 4.2 meter per second, but it's at an angle of 35 degrees to the path. Okay, so now according to our principle of conservation of momentum, it says that the momentum before collision is equal to the momentum after the collision, but we must analyze them independently. That is, the horizontal part must be analyzed separately, and then the vertical part must be analyzed separately. If you look at our question, we want to know the magnitude of the component of the final momentum of the combined object in the original direction of P. So the question is, what is the original direction of P? You can see clearly that it is the horizontal, which means that in this question, we are only interested in the horizontal aspect. So you must resolve the Q into vertical and horizontal. So the horizontal aspect, which is here, will be, you have to resolve the velocity into horizontal. That will be 4.2 cos 35. 4.2 cos 35. 4.2 cos 35. So which means, and the vertical component will be 4.2 sine 35. But in this question, we wouldn't need the vertical component. If I compute the horizontal component of Q, I'm going to get 3.44. So for the conservation of momentum, we say that momentum before collision must be equal to momentum after collision. So now let's consider the momentum before the collision. For P, it is going to your right, so we are taking it as positive. So that will be 6 times 3. But for component Q, for object Q, in the horizontal component, you can see it is going to the left. So it's going to take the opposite sign. So that will be minus 2, which is the mass, times the velocity of the horizontal component, which we have found here to be 3.44. It must be equal to the final momentum of the combined object. So this is what we are looking for. We are looking for the momentum final. So if I compute this, which will give me 18 minus 6.88, which is equal to final momentum. So 18 minus 6.88 will give me final momentum will give me 11.12. So my answer is B.